Okay, good afternoon. So welcome to our webinar today on new building materials versus concrete. So we know that concrete has been the most widely used building materials right now, but it's causing a lot of problems for our environment. However, we have new building materials to be developed and to be used to replace concrete, which can be a good solution for environmental protection. So in the webinar today, we have 16 Master 1 students from our programs in materials at UPPA, and they want to share their knowledge and perspectives on a few new building materials versus concrete in terms of, you can say, manufacturing, technical properties, life cycle, environmental impact, and if those new materials can replace concrete to help achieve sustainable development. Okay, so I will pass it on to our first group, who are gonna discuss hempcrete versus concrete.
Hello. In this presentation, we will present the difference between hempcrete versus the concrete. Before we start, we should mention that the hemp can be found in the whole world and with a good percentage. So we won't have any problems in terms of raw material in the future. And I will let my friend Bastian to talk about hemp.
So during my presentation, I will introduce you what is hempcrete, what is made of, and its benefit. So first, hempcrete is a biocomposite composed of hemp. It's the inner piece which remains when fibers are separated. These fibers are bound with a binder that can be the lime, CaO, and this reaction occurs thanks to water. And this combination of hemp and lime make it possible to create a natural lightweight concrete. What is hemp? So hemp is a subspecies of the cannabis sativa plant, but hemp has a low THC content. THC is an active molecule of the cannabis. So here we have a THC molecule. And to have an idea, they are about 4 to 9% of THC in the cannabis. Hemp can grow without the use of chemicals and requires a little water and contributes to the regeneration of agricultural soils. Hemp reaches its maturity after 11 weeks, growing up to 10 centimeters per day, and reaches 6 to 12 meters at maturity. And during its growth, hemp absorbs a high quantity of CO2. So we can say that hemp cultivation is environmentally friendly because little water, no chemicals, and a good absorption of CO2. Then, what is lime? So lime is a mineral, the calcium oxide. It's easy to produce because we have to firing limestone rocks at high temperature, around 1,000 degrees. Why use hempcrete? Because it's a very versatile compound material. We can use it for wall construction, roofing, insulation, but for other projects like new buildings or renovation. But according to my research, this technique is mainly used in Europe, maybe due to restriction, because in France, only industrial hemp can be planted only if the THC content is below 0.2%. Now, why Emcreate for walls? Because Emcreate naturally regulates the internal humidity through the walls, prevents the growth of mold and bacteria. The walls are cool in summer and warm in winter, so we have a comfort temperature. And Emcreate is a very resistant against fire. Now Yassine will introduce you the concrete.
The concrete is the most useful material in construction, and it comes in two types, block concrete and reinforced concrete, that we add a matrix of steel. So what is the component of the concrete? We have many of them, but we start by granular. They are small size, 1 to 63 millimeter. It's depend on Moroccan norm, M10. And the most component is the cement that's used to stick ground between them, and mostly it come with the silicon carbon, CaCO3, and the additives that we use to have more properties like water resistance, for example. And the most component it's water, because we need to use water not more and not less to have a good properties of concrete. But concrete have many problems. For example, the pathology of concrete, we can have like a cracking because we use less water or we use more water. Also, the most known pathology, it's the degradation of concrete because of corrosion of the matrix steel. So this is like a mechanism of this degradation. The water comes through the pores to the matrix. Then the product of corrosion push up the concrete. So we have we broke our concrete. My friend Karim will talk about the properties.
So now in this part we are going to compare hempcrete and concrete. And so let's start with the phonic insulation part. So the sound is divided into two categories: the airborne noise, which is the sound of your voice or for the music, and the impact noise, which come to the shocks or for like the step foot, for example. So these two type of noise will be reduced by two properties of the material. So the sound insulation for the urban noise and the acoustic absorption coefficient. So this coefficient is a rate, and if it's equal to 0, this means that the material doesn't absorb the sound is totally reflected. And if it's equal to 1, the sound is totally absorbed. So as you see, the reduction of the sound for the two materials is the same, but the coefficient is 0.1 for the concrete and 0.8 for the hempcrete. So the insulation for the hempcrete is very better for the sound insulation. So now the thermal insulation. So for this part, we are going to see only the thermal conductivity of the materials. And so the more insulating a material is, the lower its thermal conductivity will be. So as you can see in this table, the thermal conductivity of the hempcrete is much lower than the thermal conductivity of the concrete. And this is a treated concrete. So this is not a basic concrete as you can find in the commerce. So the hempcrete is a better thermal insulation than the concrete. So now we are going to see the reaction and the resistance to fire. And for that, we are going to see two major properties. so the combustibility of the material, which correspond to the heat emitted by the materials when it burns, and the flammability of the material, which correspond to the quantity of flammable gas emitted during the combustion. So for that, we are going to interest to only the French classification. And as you see, this classification is divided in 5 categories. So M0 is the best, and M4 is the worst. And as you can see, concrete is non-combustible, so also a non-flammable compound. And the hempcrete is in the category just below. It's a combustible material, but non-flammable material. So now the mechanical properties. So for that, we only see the compressive strength. You can see for the concrete, it's a 20 to 50 megapascal. But in hempcrete, it's only 0.1 megapascal. So that means that the hempcrete can be a load-bearing wall, and it's not used for large building. So now Nurbol gonna present his part.
So in my part of our presentation today, I'll be talking about the benefits and constraints of the hempcrete in comparison to the concrete. So starting with the benefits, since it's a it has a high vapor permeability due to the mixture's ability to absorb high water vapor from the air. And in frame architectures, it can be used as an infill material in the walls. So higher density of the hempcrete mixture allows the production of roof or floor insulation hempcrete materials, while the lower density allows the manufacture of the indoor and outdoor plasters. And it can be laid without any covering or can be covered with finishing plasters. So now talking about the disadvantages, since it's plant-based, there's a precaution against rising water and the damp levels. So walls should be built with a joint, so between the wall and the ground, and it should always be built above the ground. So external walls must avoid the rotting of shafts by applying protection by the rain sand and lime plaster. So in the next slide, I'll be talking about the life cycle assessment of hempcrete. In this figure, you can see an overview of CO2 uptake by hempcrete. So this is from a study. So just like any other crop, during its growth, it absorbs CO2 from the atmosphere for the photosynthesis reactions. But during the block production, there is a lot of CO2 emitted as well. But though after the production, during the life of the block, there is a process called carbonation. Basically, it's a reaction of, in chemical terms, it's a reaction of carbon dioxide with calcium hydroxide or calcium silica hydrate to produce calcium carbonate and water. So basically, it absorbs more CO2. In the chart below, you can see the greenhouse gas emissions balance per meter square of hempcrete wall. So the black line above corresponds to the greenhouse gas emissions, while the orange, yellow, and the green light, the line corresponds to the CO2 uptake. So as you can see, there is much more CO2 uptake than the greenhouse emissions. That means there is a negative carbon footprint, which is favorable. In the next slide here, I'm going to show a study results. So basically, it is known that the binder, as the concentration of the binder increases, so the CO2 uptake level also increases. So basically, in this study, the researchers tested 3 different binders. NHL stands for natural hydraulic lime, OPC stands for ordinary portable cement, and MK for metakaolin. So basically, the general trend here is that as the concentration of the binder increases, so does the carbonation potential. So the orange and the violet colors correspond to the calcium hydroxide and calcium silicate hydride optic. And in my last slide here, I'm just going to show another study result. Basically, this is just to reiterate the claim that there is the hempcrete is more favorable and better for the climate. So in this study, the researchers tested different scenarios. These scenarios correspond to different concentrations of binders. And binders are, by the way, this is the ingredient in the hempcrete mixture, which keep all the ingredients together. So what we can say here is that just like I said in the previous slides, the black lines correspond to the greenhouse gas emissions, while the lines below correspond to the CO2 optic. So in all cases, there was much more CO2 optic than the greenhouse emissions. So which means it's favorable compared to the concrete. So that's the end of our presentation. Thank you for your attention.
For our presentation, our group will discuss about timbercrete versus concrete. The main point of our presentation will be what is timbercrete, the mechanical properties of timbercrete, the comparison between timbercrete and concrete, its environmental impact, its advantages and disadvantages, the different application of this material, and last, a conclusion. So now Hugo will talk about what is timbercrete.
So to begin, it's important to present what is timbercrete and what it is made of. Timbercrete was developed by Australians in order to reduce the negative environmental impact of other materials. Timbercrete is a building material which is at this time only in Australia becoming a real alternative for concrete and wood. It has really good properties, and this material can be used as blocks, bricks, pavers, or panels, and really wide range of colors and size. We can ask ourselves what it is made of to have such good properties, but in reality it's really simple, because timbercrete is just a blend of cellulose, cement, sand, binders, and some other materials. So now I will present the properties of timbercrete. One of the most interesting properties is the density and the matrix of timbercrete. The density of timbercrete can be varied between 900 kilograms per cubic meter and 1,500 kilograms per cubic meter. So it allows it to be used in a really wide range of application and to meet the different construction needs. This property of timbercrete provides him really good thermal properties. So the cellulose content of timbercrete gives it what is called thermal dynamic. So for example, timbercrete has an exploitable thermal mass, which means that the material is able to store enough heat before let it evaporate. There is also more properties about thermal with the thermal conductivity. And other properties of timbercrete is about fire resistance. Some tests have been made in a laboratory to show that timbercrete has the highest possible fire resistant weighting, outperforming all other materials. Further tests have also been made in the other condition and have showed that it also have a really good performance. So it's interesting because it shows that timbercrete can be used in all possible meteorological conditions. One more extreme and applicable properties is about the bulletproof of timbercrete. So some tests have determined that timbercrete can absorb the different bullets when you shot with some guns. So this is interesting because it shows how compact is this material.
So now I will compare the. Now I will talk about I will compare the mechanical properties of concrete and compare them to timbercrete. As you know, concrete is actually the most used construction material in the world, and there exist different kind of concrete. But here we will focus on the most simple one. So I will begin with the fire resistance, which is a very important parameter. Indeed, the fire is one of the most common source of building destruction. And knowing this material was invented in Australia, this where we can see a lot of wildfire, it's an even more important parameter. So to measure the fire resistance, we use a very simple experiment. So we make a wall of our material with one side inside of a furnace and the other side in the open air. Then we obtain the two graphs we have here. So on the left we have the graphs for timbercrete, and on the right the graphs for concrete. The furnace will heat up the walls to over than 1000 degrees, and we measure the temperature of on the other side of the wall for 4 hours. And in the end, we can see the temperature of the wall of timbercrete here at with 64 degrees, and for concrete at 90 degrees. So we can see with this parameter, with the number, that timbercrete has a better fire resistance than concrete. But I have to say that concrete has also a very high fire resistance. I will now talk about I'll continue with the density of this material. So we can see that on the table below, we can see that the density of timbercrete is around 2 times lower than concrete, which is a very good thing for our material, since lighter material, a lower density means lighter material, and lighter materials also mean a material which is easier to use and easier to construct with. The lower density also mean a better thermal insulation. Here we have the heat capacity. So the heat capacity is the energy needed to increase the temperature of the material by 1 degree. We can see for that timbercrete has a better heat capacity, which means its thermal insulation is better than concrete. In addition, we have the graph above, which represents the thermal efficiency of timbercrete compared to other materials. There is no concrete is not represented on this graph, but concrete has a thermal efficiency similar to mud brick and brick veneer, and so we can see that timbercrete is better than concrete in terms of thermal insulation. Finally, I will talk about the sound absorption. So we have here the noise reduction coefficient, and so the NRC of timbercrete and concrete. We can see that timbercrete has an NRC of 0.15, and concrete has an NRC of 0.04, which means timbercrete has clearly a better noise reduction than concrete, and so has a better sound absorption. And to finish my part, I will just say that overall, for the for the characteristic I presented, timbercrete is a better material for in terms of mechanical properties than concrete.
So now I'm about to talk about the part about environmental friendly. So timbercrete is very friendly from its raw materials to its everyday use. Like Hugo say, its main ingredient it's timbercrete. It's recycled timber waste, so it's just cellulose. It has a lower embodied energy, and it acts at a carbon trap. And on top of all this, timber has an improved insulation qualities. So that means that timbercrete homes are more energy efficient through the year. So now about the part of timbercrete acts as a carbon trap. So like I said, timbercrete main ingredient is cellulose, and this ingredient it's mainly used for fertilizers. So it's used in floor covers for host stables, or it's just simple discarded or burnt. All of these uses have a negative impact on our environment, because when the product breaks down, it releases carbon dioxide gases. These gases are known to be greenhouse gases. But when timbercrete waste is used to build the timbercrete bricks, this vicious cycle is stopped. So that means that timbercrete waste is trapped in the concrete tomb. Now for the lower embodied energy, so there are three main points. The first one will be no kiln firing. That means that timbercrete does not need man-made or artificial drying process, because conventional bricks need firing to improve their durability or strength, and this process take a large amount of energy, and it releases a lot of toxic gases when it is produced. Now for the energy used during manufacturing, so to create 1 meter square of wall area, we need less energy and equipment than traditional clay to produce to have the production system. For the energy to attain raw materials, when it is possible, when you build a concrete block, it is better to obtain locally sourced materials. Now for the year-round savings, timbercrete has an amazing thermal efficiency, like Hugo said. This is mainly used to save money when you heat and cool down your house. And for the last point, it is the low maintenance. That is a really good point, because you don't need to paint and repaint the brick when like a normal clay would normally have to be painted after several years.
The advantage and the drawback of timbercrete. Cost-effective is simple to manufacture and involve a low energy manufacturing process. Thermal capacity. Timbercrete has a better thermal efficiency than than ordinary concrete of or bricks. Durability, the timbercrete, sorry. Timbercrete can last as long as any other concrete product. Lightweight. Timbercrete is also 250% lighter than concrete or clay, which means that that shipping costs are significantly reduced in manufacturing in United Kingdom, and easy to work implementation. Timbercrete can be nailed and screwed into place, making it much easy to work with. And drawback: the mixing process of timbercrete is not as well defined for a concrete. For concrete, and can lead the poor quality control. The strength of timbercrete is are not yet developed and require the further testing. And the use of wood waste could have an impact human health and if mixed or other chemical. And we can see the different application of timbercrete. We can see the acoustic barrier for highway, the firewall of partition walls for commercial structures, pizza oven, cleansing panel, fire-resistant lift shade for multi-storage building, and roof tile. And thank you for the attention.
So our group will talk about the bamboo. So first we will present you a different type of bamboo. Then the application for construction. Then we will compare the mechanical property of concrete and bamboo composite, the advantage and the disadvantage, and at least a special case on a bamboo house.
Bamboo are motocotyledonous plant belonging to family of Poaceae, subfamily of Bambusidae. There are three different tribes: Bambusiae in tropical and subtropical region, Arundinae in temperate region, et Bambusidae in tropical tropical region of Latin America. There are approximately 1,500 varieties in different size: low size, main size, and giant size. The majority of bamboo are in Asia and America. Few rare species are in Africa and Oceania, but aren't in Europe. Bamboo and the environment. Bamboo plantation release 30% more oxygen than trees. Improve water infiltration into the soil, narrow leaves. Limit soil erosion, restore depleted soil. Remove toxin from the soil. And recur little or no fertilizer or pesticides to grow. Bamboo continue to be using as a building material with a different bamboo. Dutch team compare different material versus bamboo for the environmental footprint, and bamboo has a smallest footprint.
The firstly application of bamboo is used as a reinforcement in concrete. The addition of bamboo in the concrete increase the stress and reduce the density of this material. There are many applications of bamboo in construction, like floor, house, and bridge. There are more and more competition of building, like competition of London super skyscraper, and to improve the building and the green building. There are norms for the bamboo. The first describe in detail the process and connected and design the elements and clearly indicate to the user who to guarantee the durability of bamboo. The second is indicate the classification of bamboo rods and the structure, and the final is explain the classification, specification, and test method and quality of recruitment.
So, according to the previous part, we learned that we can use bamboo for composite bamboo using bamboo fibers. And in this part, we will study its mechanical properties. So for this study, two sets of experiments have been done, one with cubes and the other with beams. To create the reinforced concrete cube, we use 9 different sizes that we can see here, and for each size, 3 samples have been made, so that means 27 cubes have been tested. So the cubes have been tested for stress strain and have been compared with plain concrete cube, and the beams have been tested for flexural strength, and the reinforced beams with bamboo fiber have been compared with the same dimension beams without any reinforcement. So let's talk about the cubes. Here we have the stress strain curve for plain concrete cube and for concrete cube with fibers. So you have to know that it's only after 28 days that reinforced cube have a better strain than plain concrete cube. And it's due to the weak bond between bamboo fiber and concrete at early stage.
So here you can see that the shape of the stress strain curve for concrete cube with fibers is a linear curve showing the elastic behavior. So we can conclude that when we add bamboo fibers, the elastic modulus increase for concrete. Now, on the other hand, we have beams. And beams, so the load deflection curve for beams without any retrenchment and for reinforced concrete beam. And we can see that for the same deflection on the curves, we need to add more load for the reinforced beams. So we have a better flexural strength for reinforced beam. So to conclude, we just saw that when we add bamboo fibers, the elastic modulus increase and the flexural strength increase too. So we can say that we can use composite concrete with bamboo fibers for buildings.
We need to know that bamboo has many advantages for the construction. His strength, thanks to his stronger than other species. He is also aesthetics because he is ideal for interior design and for the construction of many elements. We need to know that he is an ecological material because he is extremely fast growing and promotes water infiltration through its dense roots. He also helps to remove toxin from the soil and restore the depleted soils. And he is, thanks, recyclable because he is being fully recyclable. But even if bamboo has many advantages, he has also some disadvantages. His overproduction and intensive exploitation, cultivation, therefore, has a direct impact on the surrounding ecosystems. He uses of chemical products for obtain the material for the construction. And finally, the transport is the disadvantages because the most majority of the bamboo for construction is produced in Asia or North America and not in Europe. Now I'm going to present you a special case on an HQE approach, which is on the blooming bamboo house. The blooming bamboo house is made of bamboo wire, fiberboards, and coconut leaves. The house is accessed using bamboo, coconuts, and so on, many products which is obtained naturally. The house is can be used for keeping animals and plants. And this is the results of our study. On this graph, we can see the 14 targets of the HQE approach. Each of these targets is very effective or basic level. We can see 3 targets as a very effective level, which is target 1, 6, and 13. Target 2, 4, 10, and 12 as an effective performance level, which is integrate choice of construction products, energy management, visual comfort, and sanitary quality of species, and all the other targets as a basic performance level. So with this study, we can say that bamboo is an ideal material for the construction. And thank you for listening.
So hello, we will present cork block versus concrete. So nowadays we use concrete in almost production, in almost building, but it's a material with very important impacts. So we will asking the question of using different material. One of the most interesting alternative can be the cork block. So we will compare the manufacture on this component on the propriety. This man is Anthony Tilston, and it's architect of all Tilston architects. He was one of the first to use the wood on the concrete in main components in his building. And he say we are responsible of the material we use, so we are responsible of the impact of this material. So in the first part we will compare how the two materials are formed. After we will see the chemical property and the physical property of the both material. And to finish, we will study the economy and the impact aspects of the two materials.
So I'm going to talk about the origin of the cork block and the concrete and how they are made. So for the concrete, what is concrete? It's a mix between several elements. To make 1 meter cube of concrete, we need these proportions of materials. Those materials are not are abundant, so they are not difficult to find. So for the process, after the extraction of the raw materials, their materials are mixed in the different proportions. So, for example, there is an example of a mix, and the composition can vary with the application we wanted. This shows the great adaptability of the concrete. So the mix is heated first in order to obtain clinker. The most used way of heating is by dry air. So we take our powder and we put it in an oven at the first temperature, which is 650 degrees. At this temperature, we have this reaction. At this temperature, the calcium carbonate is decarbonized. And after we increase the temperature at 1,300 degrees, where we have two reactions. After that, these two reactions are followed by others reaction, which will give the clinker. Then we add gypsum to slow down the cement hardening. And at the end, we have the concrete. So now for the cork block. So what is a cork block? What is cork? The cork is a natural material coming from the bark of the cork oak collected thanks to the special axes. This tree is located in the Mediterranean region. Especially the Portugal is the main producer. Over 1 year, a tree can give 3 to 7 kilogram of cork, knowing that the bark can only be collected every 9 years from the maturity of the tree. So, moreover, it can undergo 60 barking during its life. The particularity of the bark from this oak is to have an external layer constituted by cells, which form an homogeneous tissue called cork. So what is cork? It's a complex mix of polymer. Every polymer in cork has intrinsic properties, and once they are combined, this gives a cork. So to use cork for construction, it needs to be expanded. To do this, we need to heat the raw cork by water vapor. During the heat, the suberin, the main constituent of the cork, will be a natural stick. Finally, the material is cooled down thanks to water at 90 degrees. we use this temperature to avoid thermal shock. So now we will discuss the different properties of our two materials.
So we will talk about the chemical and the physical properties of the cork block and the concrete. First, we will discuss about the mechanical properties of the cork block and the concrete. So we will study the Young modulus of the material. The Young modulus is something which characterizes the relation between the strength and the strain applied to the strain to the material according to the strength applied on it. So in other words, it means that the higher the Young modulus, the more rigid will be the material. So here we can see that concrete has a rather high Young modulus compared to cork. It means that cork will be easily deformed, which is a drawback for construction, for building. We can discuss too about the volume weight. So for here you can see that the cork and the concrete has not the same value. For the same size of a material, the cork will be 10 times lighter than the concrete. It is an advantage because for transportation, it will be easier to transport cork than concrete. Another properties of the concrete is that first it is a fluid, so it will fit easily the form that you want to have at the end. And it's a drawback for cork maybe because you have a complex matrix of polymer. So this matrix will be hard to deform. If you want to have a liquid, for example, and then heat it, you can't because you will only degrade the material. So now for the chemical properties. One of the chemical properties of the concrete is it has high chemical inертness. It means that this compound needs little maintenance, and it is really important. It resists to corrosive agents such as salt water. Another thing is when you made the concrete, if you have a low porosity, you will have a liquid-proof material. The material is sustainable too, thanks to the resistivity to fire. Despite the inertness of this compound, we can have a carbonation reaction that happens in a wet atmosphere with carbon dioxide. So it will be in pores of the concrete, and in the pores you will have a densification of the material. So it is benefit. So now we can talk about the chemical properties of the cork. The cork is made of ceroid, for example, the cork bark, and this allows the material to be waterproof thanks to the high hydrophobicity of the ceroid. The material has 45% of suberin. The suberin is made of fatty acid and heavy organic alcohol that extend the waterproofness of the material to liquid proof, and relatively gas proof too. Now we can talk about the tree. In the tree we have phylogen, that is an active species during all the life of the tree. And this allows the material to be homogeneous during all its life. Two other properties of the cork is that it is a really good insulator and has a high inertness to chemical species too. And now we will talk about the economic and the environmental aspects with my colleague.
So, the concrete is responsible for more than 40% of the global energetic consumption. over a year, 6 billion of meter cube of concrete are used, making it the most widely manufactured product in the world. As we have seen at the beginning of the report, the concrete needs a lot of resources for its preparation. The raw materials are abundant and don't need hard extraction work. They are low cost but non-renewable. Furthermore, the concrete needs to be transformed for a building application. For the cork, only water is needed for the growth of the bark, which is renewed every 10 to 15 years. The debarking is not expensive neither and made by hand. And for building applications, a transformation is mandatory too. In the framework of the transformation of the material, the energy used will be different as well as produced waste. So, for example, if we look at this table, we have different values for 1 meter cube of concrete, but knowing that we need 116 meter cube of concrete to build a house of 150 meters square, these values will be multiplied by more than 100. We don't have equivalent information for the cork, but if we compare now some environmental aspects, we have a global warming potential of 235 kilogram equivalent CO2 for the concrete due to the raw material and in particular the cement. Whereas for the cork, we have a global global warming potential of 35 kilogram equivalent CO2. And this value is taking in account all the steps from the raw material extraction to the manufacturing and packaging. The transport steps are very important to consider too. And once again, after some studies, the concrete has the most higher value of global warming potential for transportation, but we think that the values are rather equivalent because we can find the concrete everywhere, but the concrete is located in a specific region, so it needs most transportation to be delivered around the world. For the end life, both of the material are recycled. At least 80% of the concrete came from destruction can be recycled into granules and used for many applications, for example, backfilling roads. And the last 20% are stored with other inert waste. The cork is 100% recyclable. This one is ground and can be used in many other applications. The most common one is the insulation, and furthermore, the cork is biodegradable.
So, to conclude about this research, we can conclude the economic aspect of the two materials as interesting, but the global warming of the cork block is more interesting for the cork block than the concrete. So, we see a building only with a cork block is not realistic actually, but we can imagine to use the both material to use the better aspects, the better property of the both to building to building. So during the research, we find the England house who was built with concrete, but for that we need to give more time to have interesting. We need hedging to know if its material is a future one or not. So we can affirm the cork block. It's an innovative material with a very low impact. But currently we need to use concrete because we can't use only a cork block for building actually. but it's probably a futurist, really interesting material for the innovation in the future build. So thank you for your attention.
Okay, so thank you very much. I hope today's webinar will be very inspiring for us to develop new building materials. Okay, and thank you again for your contribution.